Welcome to March 20th LeetCode Challenge. Can place flowers. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Given an integer array flower bed containing zeros and ones where 0 means empty and 1 means not empty, and integer n, return if n new flowers can be planted in the flower bed without violating the no adjacent flowers rule. So we're given the following as such. We have flower bed given the array here, and we want to know whether we could plant n flowers. The answer is true because you could plant the flower in the middle, right here, without violating the no adjacent flower rule. Example number 2. Similar to the first example, except this time we need to plant 2 flowers in the flower bed. Are we able to plant the flower bed? Plant the flower in the flower bed, 2 flowers, I should say, without violating the non-adjacent flower rule? The answer is no, false. Say if we were to plant 1 flower here, we have 0 here and 0 here, but there's nowhere else where we could plant a flower without violating the rule. And that's pretty much the gist of it. The constraints are that the length of the flower bed is between 1 to 10, 2 times 10 to the 4. Flower bed at each index is either 0 or 1. And there's no 2 adjacent flower beds in the flower bed. No adjacent flowers in the flower bed to begin with. The length of the flower bed is greater than n, greater equal to n, which is greater than equal to 0. So in order to kind of solve this, it's pretty, I guess we could iterate through it. Through the flower bed. If we find a 0, that means after the 0 we should be able to plant a flower. If that planted flower is followed by a 1, therefore we cannot plant the flower there, then we can just continue. So if we do a single scan approach, so I guess ideally we should be able to initialize a count. And then iterate through it, as I said before, for int I equal to 0. I less than the length of flower bed, so it'll be flower bed dot length I plus plus. First thing we do is we want to check to see if the current plot is empty, i.e. 0. So if flower bed at index I 0, then we could plant it. However, before planting, we should check if the left and right of the plots are also empty. So that would be checking for booleans, I guess. So it'll be empty left plot, and that would be equal to I 0, or the flower bed at index I minus 1 equals 0. And then we want to check also the boolean empty right plot, and that would either be the current index equals flower bed dot length minus 1 or flower bed index I plus 1, yes, equals 0. Alright, we have those two. Next thing we're going to do is if both plots are empty, being left and right, we can plant a flower at that index. So if empty left plot and empty right plot, then we should plant the flower there. So therefore flower bed at index I shall be assigned to be 1, increment the count, and then if count is greater than or equal to n, that means we have reached our objective, return true. True. Otherwise, if none of these all work, we can exit the for loop, and then I believe we just return false here. And that should solve our issue. Let's take a run here. Wait a minute. Flower bed. Run that. Alright, that looks okay so far. So essentially, oof, something wrong here. Count equals 0. Initialized. Flower bed index I. If empty left plot, empty right plot, I into 0, or flower bed minus 1 equals 0, plus 1, flower bed minus 1, equal to 0, increment count. If count greater than equal to 0, return true. Oh, not return false. We only return false if the count is equal or less than n. There you go. Run this. Awesome. So basically what we did was that time complexity wise is that so what we did is that we, instead of kind of finding the maximum and minimum value, what we did was that we could stop the position where we stopped checking if the plant becomes equal to n. Doing this will lead to kind of a more optimized approach, since we don't have to basically iterate through the entire plot. So time complexity wise is big O of n because it's in a single scan, so if the flower bed at the size of rate n is done. Space complexity is constant extra space is used. And that's pretty much it. Have a great day, guys.